Let's now have a look at an HSC question, 2003, question 10, which would be the last question on that paper and therefore considered quite challenging. It is an application of series around loan repayment, and when we read it together, you'll see why it might be considered challenging. It's important to remember that if it's a home loan repayment question, then even if the question looks unusual, you already know all the mathematics required to be able to answer it. And you shouldn't be thrown off by the question slightly looking different to what you're used to. So let's see how this is different. Barbara borrows $120,000 to be repaid over 25 years at 6% per annum, and it says reducible interest. That means it's compounded interest. Now, each year there are K regular repayments of F dollars. That's what makes this question challenging. They haven't said it's monthly repayment if it's compounded monthly. If it was compounded monthly, that K would be 12. If it's compounded quarterly, then the K would have been 4. But it doesn't say that. And in the previous example, we used M for our repayments. In this case, we're using F for our repayments. Interest is calculated and charged just before each repayment. So that's great. That's how we've been doing our calculation. Write down an expression for the amount owing after 2 repayments. Now, it's important to note that this is only worth 1 mark. So we don't need to provide copious amount of working out. But if we don't establish this, then the next part would be quite challenging to do. Let's make a summary and see if we can establish our series. We are borrowing $120,000. We are borrowing over 25 years at 6%. So N is 25 years, but there are K repayments per year, so I need to times that by K. Just like if it was 12, we would multiply it by 12. And the rate is 6% per annum, but in this case I need to divide that by K, just like if it was monthly, we divide by 12. Okay, so first month, principal. Now we know how this works. 1 plus 0.06 over K to the power of 1 minus F. A2 would be A1 times 1 plus 0.06 over K minus F. And then once we substitute A1 in, hopefully you've done so many of these that you know what it's going to look like. So I've come up with an expression for A2. I have 120,000, this thing here, squared minus F, the same thing to the power of 1 and then plus 1, as we had in our previous example. Part 2 says show that the amount owing after N repayments is given by this. So now they're saying establish a pattern, generalize from the pattern, and show me this formula, derive this formula, and that thing that is a little bit challenging to write, 1 plus 0.06 over K, can be rewritten as alpha. So let's have a go at that. I am first of all going to let alpha equal to 1 plus 0.06 over K and rewrite this for part 2. So A2 is 120,000 times alpha squared minus f alpha plus 1. Just means my working out will look neater and it's easier to follow. And remember, we need 3 to establish a pattern. So I've had 1, I've done 2, now it's A3, that's going to be 120,000. Actually, we need to do the working out, so that's going to be A2 times alpha minus f, which is substituting for A2, expanding the brackets and refactorizing, and then generalizing. So dot 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 a, and now where are we up to? It would be, how many years did we have? 25. So 25k, they've called it n, so let's do an is going to be 120,000 alpha to the n minus 1 n minus 2, and then as before we state this is a geometric series. Now you'll see some people, some other teachers and in textbooks, they refer to this sometimes as GP, for geometric progression, and that's fine. I use geometric series because we are learning about series and I like to use the language that's part of the syllabus, but geometric progression is there as well, and you can write GP instead of geometric series when you're doing your working out and setting out your solution. So as before, A is 1, R is alpha, and N, well, N is N. So AN and that sort of looks like what was in the question, except they have K and 0.06. So let's see how we can reintroduce that back in so that it looks as required by the question. So what was my alpha? My alpha was 1 plus 0.06. So let's replace alpha in the denominator by this 120,000 alpha to the n minus f alpha to the n minus 1 over alpha is 1 plus 0.06 on k minus 1. The ones will cancel by doing my fraction division. I end up with what the question required. So that's right. Therefore, an minus k f alpha to the n minus 1 all over 0.06 as the question required. Next part, part 3. Calculate the amount of each repayment if the repayments are made quarterly. So now this should simplify things. Let's work out what our alpha is for part 3. So k is equal to 4. Alpha is 1 plus 0.06 on 4, which is 1.015. So I know my alpha, I know my k, and I know my n. N is going to be 25 times 4, which is 100. So, and also of course we have to remember a 100 is equal to 0. So 0 equals 1, 2, 0, 0, 0, 0, 1.015, to the power of n, that's 100. Then that's minus, let's put the f out, k, which is 4, 1.015 to the power of 100 minus 1 all over 0.06. As before, a bit of algebraic rearrangement. We do that calculation, which gives me $2,324.47 to the nearest cent. Okay, last part. How much would Barbara have saved over the term of the loan if she had chosen to make monthly rather than quarterly repayments? So we now need to do the calculation with monthly repayments and compare our result for monthly as opposed to quarterly. And what we're looking for is really how much would she have saved for the duration of the loan, not just per month, but it doesn't say per month. And if you read it carefully, how much would Barbara have saved over the term of the loan? It's asking for the total savings once it's all been paid for. So if I want to know how much she has paid, I need to multiply the monthly repayment by the number of repayments and then compare those results. So part 4. K is 12. We need to work out our alpha. We need to work out our n. And then again, well, that's 25 times 12, which is 300. And our alpha is 1 plus 0.06 divided by 12, which is 1.005, and 300 is 0. So I'm just going to quickly do this calculation and then we'll do our comparison. Alright, now I have my monthly repayments as opposed to quarterly, so the savings would be $2,324.47 times by 100 minus $773.16 times by 300, which is $499. So that's how much saving there is. And again, I forgot to write a sentence answer for the end of part 3, and I need to write a sentence answer for the end of part 4, but I'm sure you can do that.